Good morning, majors. So today we're going to go over notes for Unit 7, Day 4. So you guys should have done the video for trig. And this is just going over inverse trig. What that means is they're going to give you your side lengths and they're going to ask you for the angle. So we're going to do the inverse of trig. This is Unit 7, Day 4. Okay. So this first part is a warm up. You can plug these into the calculator. Use the Pythagorean theorem to find AC. So inverse trig, we're gonna use this to find the missing acute angle. Remember, we cannot use our reference angle cannot be the 90-degree angle. So instead of sine of A being opposite of our hypotenuse, this is what it means. The sine inverse of opposite of our hypotenuse is equal to the angle. So this looks a little confusing, but I'm going to go over these with you. I'm going to explain it. So most of the time, we can just plug it into the calculator, which is really nice. But if sine of A is this decimal, then A is equal to the sine inverse of the decimal, 0.4384, okay? So we're trying to find the angle. They're asking us for the angle. So I'm going to go to my calculator. I'm going to always make sure that we have our mode is on degrees, because when we clear them for the SOL, it's going to go back to radians. So, and if they're off too long, then they go back to radians by themselves, because it's like standard for calculus. But for in this case, we're going to always use degrees. So to get sine inverse, do you guys see above here, this little blue thing says sine to the -1. So we're going to do second sine, and that'll give us sine inverse. And then just plug in the decimal. Don't round, keep everything. 0.4384. So 0.4384 parentheses, enter. What degree is that? Actually, they did it right here, right? Oops, this is my calculator. So my degree, the measure of angle A, this little M means measure of angle A, is about 26 degrees. I'm just going to leave it like that, 26 degrees. Put a little degree symbol. So if cosine of B is 7/8, then cosine inverse of 7/8 equals B. So let's find that out. The cosine inverse, so again, we're going to do second cosine of 7 divided by 8, and your parentheses, equals 28.955 is 28.96 or 29 degrees, whatever you want to round that up to, 28.96 degrees. The other 5 rounded this one up to a 6. All right, guys, try tangent inverse of 9/5. Try it out. Find out what this one is. What is Q? All right, go ahead and flip your paper over. Find the measurement of the angle by setting up a trig ratio. We need to know which trig ratio to find or to use. So remember, I'm going to write down SOHCAHTOA, S-O-H. We still need this. C-A-H-T-O-A. We can't just pick any old trig function we want. We have to pick the one that works. So they're asking us for the measure of angle A. So that means that angle A is my reference angle. Remember, my first step is to circle my reference angle. My second step is to label my sides. My opposite side is 7, right opposite next to it. This is my hypotenuse. It doesn't have a number, so I'm not going to really label it. You can if you want. But the 6 is my adjacent side. So which trig function uses adjacent and opposite? Adjacent, no. Adjacent, yes, but opposite, no. Adjacent, yes, and opposite. Good. So we know it's tangent. So we're going to write it out. Tangent of whatever A is equals, we know the ratio. Remember, opposite comes first, which is 7, over adjacent, which is 6. Now, we can just plug this into the calculator, but we need to know what A is. So we're going to solve for A equals the tangent inverse to the -1 of 7/6. So let's go back to our handy dandy calculator, and we're going to put it in tangent tangent inverse, so second tangent of 7 divided by 6, parentheses, enter. And that's 49.4-ish. So I'm going to write that down. 49.39 is 49.4 degrees. Put a little degree symbol above it. These are all in degrees. If they were asking us for angle B, we could just subtract it from 90, right? If this is 49.4, we can also find angle B if they wanted without doing trig. All right, it says find the measure of this angle. My reference angle is angle M. So I'm not using O, and I can never use my right angle. I can never use N. But I'm going to circle M. And so I'm going to circle my reference angle. That's my first step. My second step is to label my sides. My opposite side is blank, so I'm not going to use that. My hypotenuse is opposite the 90, so that's 11, HYP. That's my biggest side. And the other side is my adjacent side. So which trig function uses adjacent and hypotenuse? Adjacent and hypotenuse, no, this is opposite. Adjacent and hypotenuse is cosine. So we're going to use cosine of the degrees, which is angle M, we don't know what that is yet, equals, they told us to use adjacent, cosine's ratio is adjacent on top, which is 5, divided by my hypotenuse, which is 11. Now we cannot write it, we cannot plug it into the calculator like this, so rewrite it how we write it into the calculator. M equals the cosine inverse of 5 divided by 11. We're only going to use the inverse functions when we're asked for the angles. Okay, we're going to be given the side lengths, they're asking us for the angle. So I'm going to use cosine, click on that. So we're going to use cosine inverse, which is second cosine, and then my ratio is 5 divided by 11. So I'm going to plug in 5 divided by 11. What angle is that? What is my degrees? 62.96. 62.96 degrees. I want you guys to try this one out. Solve the triangle by finding the missing sides and angles. Okay, so in order to find the third side of a triangle, we can use the Pythagorean theorem, or we can use trig. It's up to you. I'm going to show you using trig, but if you were going to find this side using the Pythagorean theorem, it would be 8 squared plus this side is maybe x squared equals the hypotenuse, which is 16 squared. Okay, so that's how you set it up. You can do it that way. I'm going to find the third side using trig, but I need an angle. So first, I'm going to pick one of my angles. I think I'm going to pick this one, okay? And I'm going to find out what the measure is. So I'm going to first circle my reference angle, which is right here. And let's make it A, because I don't know what it is. I'm going to make it A. And my second step is to label my sides I do have. So my opposite side is 8. This is OPP, opposite. And my hypotenuse is 16. So this is HYP, hypotenuse. Right? The adjacent side, there's no number or variable, so I don't need it. We could put an X there, but we don't need that right now. So I'm going to use opposite and hypotenuse. Hopefully you guys have SOHCAHTOA written on your paper. And opposite and hypotenuse is sine. This is something you need to remember. Sine of angle A equals, opposite comes first, so that's 8, over hypotenuse is 16. That's still the same as 1/2, but we don't have to simplify it. So A, angle A, is the sine inverse of 8 over 16. So let's plug that into our calculators and see what happens. So second sine of 8 divided by 16. What if we had known that that is the same as 1/2? Let's see what happens. Second sine, what if we simplified it and made it 1/2? 8 over 16 is the same as 1/2. What if we simplified it? Doesn't matter. Is it going to change our angle? No, it's going to be the same. As long as the ratio is 1 to 2, it'll be 30 degrees. Okay, we know this from our special right triangles. So If you guys can figure this out, right here is 30 degrees, you guys can figure this one out. This one is 90, this is 30. Remember, they add it to be 120. Subtract that from 180. I hope that you guys remember this is a 30. 90, this one has to be 60 triangle, right? And our last step would be to find this third side. Like I said, we can use the Pythagorean theorem, or we can use sine, cosine, tangent. So I'm going to use sine, cosine, tangent. I'm going to circle my reference angle. My opposite side and my hypotenuse is already labeled. I'm just going to label x and make that my adjacent side, right? We're trying to find my adjacent side in this one, so I need to use adjacent with one of the other ones. It doesn't matter which one you use. I'm going to use adjacent and hypotenuse, okay? So which trig function uses adjacent and hypotenuse? Look up there. Sine, cosine, or tangent. Cosine of 30 degrees equals my adjacent over my hypotenuse. You could have done a different trig function. You could have used tangent. Sine would not have helped you. All right, so in order to solve this, I need to solve for x. So I'm going to cross multiply. 1 times x is x. Cosine of 30 times 16 is 16 cosine of 30. Remember, we cannot multiply 16 and 30. They're not multiplyable. So I'm just going to plug that into my calculator. 16 cosine of 30. What is that ratio? So it's 13.86. The side length x equals, what do we say, 13? 13.86. If they asked me for a square root, maybe simplest radical form, I could not use trig. I would have to use either my ratios or the Pythagorean theorem. You could use your ratios on that. It's a 30, 60, 90. All right, guys, try number 2. Try it out. This one you guys can definitely do. Use the sine, cosine, tangent, inverse. Let's try this one. An 8-meter pole, so the length of the pole is 8 meters, is leaning against a tree. The foot of the pole is 5 meters from the foot of the tree. What angle does the pole make with the tree? So they're asking you for this angle right here. They're asking you for theta. So my first step is to circle my reference angle. My second step is to label my sides. My opposite side is not given. We don't need that. My hypotenuse is going to be 8. And my adjacent side is 5. Okay, so which trig function uses adjacent and hypotenuse? Cosine. So I'm going to say cosine of the degrees, whatever theta is, equals adjacent comes first, which is 5, over hypotenuse, which is 8. All right. Now, to get theta by itself, I'm going to take the cosine inverse of both sides. So theta is equal to the cosine inverse of 5 over 8. So let's find out what theta is. That's what they're asking us for. What is the cosine inverse second cosine of 5 divided by 8? 51.3 degrees. That's what they're asking, the pole. Great. I want you guys to try to do the rest. Try to fill out the rest of these notes. And I will see you in class tomorrow. Make sure you ask any questions that you may have in class. Have a good night.